Hey guys, so we're going to go through this video lesson on the ideal gas law or ideal gas equation. You'll see here that it's an equation that's going to combine Boyle's law, Charles' law, and Avogadro's law, which you're going to learn on another lesson coming right up on the molar volume and solution stoichiometry. So the first thing you need to know is the ideal gas law equation, and that is this equation right here, PV equals nRT. So say it over a few times, you need to know it. PV equals nRT. Some people just say PIVNERT because that kind of works for them, whatever. PV equals nRT. And what do those mean? That means you have a pressure times a volume of a gas would equal the number of moles of that gas times the temperature of that gas times this value R, which this is what's called a gas constant. It's just a constant number that stays that same number, 0.0821. This is important because this has these very specific units attached to it. Some people write it like this, 0.0821. What's really saying is liters times atmosphere divided by moles times Kelvin. That's essentially what I tried to write for you up here or type for you. But that's just a gas constant that's going to stay. The other units are important and mandatory for using the ideal gas law. What I mean is, anytime you're going to use this ideal gas law equation, your pressure must be in atmosphere, volume must be in liters, the N, it must be your amount of moles, temperature, just like the others, must be in Kelvin, and of course this value has this unit attached to it. Alright, so overall, to use this equation, you must have these units. Alright, mandatory. Okay, so I have an example problem here down below. We're going to go ahead and take a look at and use that to go ahead and solve this problem so you see how this works. What volume? This is, of course, volume of a gas is occupied by 5.03 grams of oxygen. Oh, that really should say O2. Sorry about that, not having the subscript. At 28 degrees Celsius, and then a pressure of 0.998 atmospheres. So first thing you want to do is go ahead and write out your equation, PV equals nRT. Okay. And there's a couple of ways to approach this. You can go ahead and plug in the values and then rearrange it to solve for V, or the volume. You can go ahead and rearrange the equation now. So if we were to do that, you would just divide both sides by pressure, right? Because we're trying to isolate the volume. Therefore, we would determine that volume is equal to nRT over pressure, right? And then you can go ahead and plug in your values. So let's just take that approach since we kind of started that way. But before you can really begin, you have to make sure these units are correct. And remember, you just learned some very specific units. Pressure, whoops, that pressure has to be in atmospheres, volume has to be in liters, which we're solving for, N is in moles, temperature is in Kelvin, and then your R has those specific units. So this first thing here we've got going on in this equation, volume is occupied here at volume, or the grams rather, of oxygen. We need to convert this into moles of oxygen. So let's go ahead and do that one right up top here. Take our 5.03. What is wrong with me today? Alright, 5.03 grams of oxygen divided by your 32 grams per mole. You guys have been doing this now for quite some time. Of course, that means that your grams are canceling out, and ultimately you end up with 0.157 moles of oxygen. So hold on to that. We're going to come back to that because this is our N value, right, in our equation. All right, so let's take a look at the next thing we've got going on. Scroll this down a little bit here. We've got this temperature here. It's right now it's in degrees Celsius, but you of course remember that we must convert to Kelvin. All right. Okay, so all we're going to do is just take the 28 degrees Celsius. We're going to add 273. That's going to tell us that we have 301 Kelvin, right? And then this, of course, is our value for T, for temperature. Okay, pressure, it's easy for us. It's already given to us, it's an atmosphere. If this was not an atmosphere, then you would need to convert it to atmosphere, but since we got lucky with this one, it was already an atmosphere, then there's nothing to do, nothing to change with that one. So let's go ahead and plug in our values. Okay, so then, using this equation here that we've already simplified to solve for volume, say that volume is equal to N, which we just determined, right, is up here, this little number here, N, right? So N is equal to 0.157 moles, right? R, which is our gas constant, remember the gas constant value, which we've got right here, is your gas constant R, okay? 0.0821 liters atmosphere over moles times Kelvin. And then your temperature, which we've got here is in Kelvin now, 301 Kelvin. And all of that is going to be divided by E, our pressure, which we didn't have to do anything with. So it's 0.998 atmosphere. Okay, so when you go ahead and you multiply across the top, you divide by the bottom. This moles is going to cancel with this moles here. This atmosphere is going to cancel with this atmosphere. Kelvin is going to cancel with Kelvin, and look what we're left with. We're left with liters, which is a unit of volume. Wow, doesn't that make sense? So we're going to go ahead and multiply everything across the top, divide by the bottom, and you get 3.9 liters. Done. And that's it. That's the ideal gas law. That's all you have to do. You're going to get, you'll always have the gas constant R. You'll get some other values. Maybe another example, you would solve for pressure. So then you would be given your volume, you would be given your number of moles or the grams to convert to moles, and then temperature and so on and so forth. I do want to just make one quick note for the IB students. All right, so for IB, if you look in your textbook, and you see the gas law, the ideal gas law, according to IB, okay, they're going to have the same equation, of course, but they give an R value of 8.31 joules per Kelvin per mole, and then their pressure is in the unit of pascals, okay, which is the same thing as Pascal, PA. This is a totally acceptable way. You can also use this to solve for problems. Certainly, if you were given a pressure in pascals, then you can just use this gas constant R instead of the 0.0821 value that I gave you. Both will give you the same answer ultimately. It's just a matter of different conversions. So you can take your pick on which one you like to use. I just wanted to point that out to you for those of you who are book people and you're reading the book and you're saying, wait, Miss B, the unit is different and the number is different for this R value. That's all that was. Okay, that's it for the ideal gas law.